Hello guys, welcome back to the object-oriented programming in Python. In the previous session, we talked about polymorphism, but today we will talk about three different methods in Python classes: the class methods, static methods, and Python-specific Dunder methods. In Python, not all classes belong to one object. We have two special kinds of methods in addition to the normal instant methods. Class methods belong to the class itself, not any single object. Static methods are utility functions inside the class that do not depend on the instance or the class. Okay, let's define the class from scratch again. So this code belongs to the previous tutorials. Let's create a new file that we said that this is OP session 4, of course. And let's define the class again. So we define a class chatbot. Just copy paste the name, and we define a variable called bot count. The bot count basically is the class attribute. Let's define the initialization method. And here in the initialization, we add the bot count be actually +1 whenever we create new object out of this class. Okay, to define the class method, we use something like this. So @ class method, then Python understands that this method is class method, not the normal method that we defined before. The class method is basically how many dots that we have. As you can see, we define this attribute bot count inside the class, but instead of using self here, we use CLS. CLS is basically the class methods that we define here. From Python point of view, it accesses the class itself, and whenever you call the attribute variable that you define inside the class, the attribute variable will be called from the class. In this method, we want to get the return on how many objects have been defined from this class. The static method looks like the class method, but you use @ static method. In this case, we define something like is greeting. And here as well, we only need to add the input variable, not self. And we want to return the message. So if you want to run and check how those kind of methods are working, let's define bot1 and bot2 with the chatbot. The bot1, we keep the same of Aiden, and bot2 is Zara. Then we print the chatbot. How many bots do we have? It returns us the static method true and false. In case that message is hi, hello, and hey, it returns true. In case it's not, it returns false. Let's run it to see what will happen. As you can see from the output, there are currently 2 chatbots have been created from the chatbot class. And this is returned by our class method. As you can see from the how many bots, the CLS variable correctly called the class and correctly called the bot count from the attribute of the class. A static method, however, it doesn't need CLS or self at all. It is just the helper inside this class. A common use for class methods is building factory methods, which is alternate ways to create an object. Just as an example, let's see in this way. Let's define a class method that we want it to act as a way to create instance if we call it directly when we want to create, for example, the new bot called Nova. Let's define it like this. For example, this is the method with the CLS, of course, and you want to get this data. Data in that sense, we have only bot name, so the name would be the data that we want to give. But let's keep it general, and we return the CLS and data. So let's write it here. We call it bot3 and chatbot from a string, and let's call it Nova. And if you print the bot3 name, Let's run this. So in that case, we need to get the Nova data expectation. Let's see if we get the same variable. As you can see, bot3 returns Nova. One question is that what will happen if we add the previous class method, which basically points out to how many bots do we have after bot3. If I want to confirm is if there are 3 bots have been created or 2 bots, we can check it like that. Let's see it again. Nice. As you can see, there are 3 bots now. So this is the new way to create this instance by calling this class method directly. This is useful when you are creating the bots from external resources like files, configs, APIs, so on and so forth. Python has many special methods that start and end with double underscore. For example, you already saw initialization, but there are also other methods, which are often called Dunder methods. They let us control how objects behave with built-in functions like print, equal, or any other functions that you use in Python. Let's define some of these Dunder methods inside our chatbot class to see how they are working. Let's add it after our static method. We define the first one from str. What it will return, however, is different. It will return the chatbot name. The another method that we want to define is representation. So what we say is that the representation basically shows the object that we have. And last but not least, we define the equality. So we define other instead of variable. It basically returns if other is instance of chatbot class or not. But we want to also, we can also define like if the chatbot name of the other also equal to this specific class that we have, the self name. Let's use our already defined 3 chatbots that we had. We delete all the print functions. Here we put the bot1 inside the print function, and print function accepts a string. But in the Dunder method of the class, we already define whenever we want our class to be behaved or to be handled like a string, what kind of data it needs to return. So the expectation here is it returns chatbot name is self name. But let's see if in practices, you can see chatbot name is Ada. So it behaves exactly that we define inside our class. Let's check the another one for bot1. This is the representation Dunder method or the magic method that you can use it to represent the class itself. We have to see something like this, but we'll see how it works. Yes. So the representation, since we already put it in an array, it shows that this is an object with the Aiden as we created here to be represented like that. Okay, the another is equality. So equality, we said that bot1 if it's equal to bot2. When we add this equality, this Dunder method will be called. And as they expect, it returns false. Let's test additional thing here. We want to check if bot1 is equal bot3. In the case of Big Nova, they're not the same, of course, but let's change this one to Aiden and see what will happen. As you can see, it returns true. It basically validates 2 points here. The first one, of course, is the Dunder method that's working both in the case of unequal classes and equal classes. And the another one is that we define this class method, which also create the object in different way. And here we prove that even when we use the class method, it shows that this class method create an object in the same way that we create here. There's no difference between them, only the way that you create it inside your code. With Dunder method, we can also overload operators. For example, what if we want to add 2 bots together to join forces? Let's see how that can be implemented. We can implement it as additional. So we want to add the other class to the self class. In that sense, we say that self name. As you can see, this other name is white here. Now let's delete these ones and we want to print something like this. the bot team is bot 1 plus bot 2. And we want to print, of course, bot team. Now we are dealing with two Dunder methods that we define. The first one is this add, which we use it here. And the second one is this string, which returns the name of the chat. Okay, the chatbot name is now Aiden Zara. So we redefine this plus operator sign inside our own class by our own definition. And we basically overload the operator here. In this example, of course, we use the simple use cases in order to show how this works, but for more complex setups, you can use them in any way that you want for your object and for your classes to be handled by your code. Now it's a time for your challenge. For example, add the Dunder method of length to your chatbot, and it returns, for example, how many characters does your chatbot have. And also add a GT Dunder method or grade, in which you can compare two chatbots' name and to show which one has longer name. Awesome work! You just level up your Python skills in classes and object-oriented programming. In the next video, we will explore composition and final design of the chatbot, which is really important whenever you want to program your whole architecture as a modular program. And you want to, for example, break your bot into smaller components for the cleaner architecture. Until the next video, good morning, good afternoon, and good evening. Bye.